Good morning, students. Today our topic is the principle of superposition of waves. So what is the definition of the principle of superposition of waves? Means when two or more waves traveling in a medium overlap, then the resultant displacement at any point in the medium is equal to the algebraic sum of the individual displacements of the wave. If suppose here it is the particle, this particle is vibrating up and down, then the graphical representation for this like this. If it is going up means like this, and next going again down means this particle, then it is the representation up and down. So this up means the amplitude is maximum, and down means here the amplitude is maximum, but it is in a positive direction, it is in negative direction. So it is up and down. Here in between it will become 0 amplitude, maximum 0, maximum 0, maximum 0. So here it is called as it is oscillating. That means it is oscillating. Here this particle is doing oscillation. So then it is the graphical representation for this. If suppose two or more waves, it is the one wave. If it is the another wave, if it is the, I will draw dotted. These two waves are interfere, then the resultant amplitude, here this is the amplitude is maximum, and here it is the amplitude for this dotted line. So these two are interfere, then we are getting the maximum amplitude. So what you understood from this, when it is a crust and it is called as the trough, and it is a crust and it is called as the trough. When the crust is interfere with the another wave crust, then we are getting the maximum amplitude. So here it is a crust is overlapped with the another, trough is overlapped with the another trough, we are getting the maximum amplitude. So then this is called as the this is called as the superposition of the waves. So like this, if suppose these two are the waves traveling in a medium, so at this point, if suppose at this point the resultant displacement is here, the resultant displacement is like, so then here how it will become, so if it is A1 is the displacement of the one wave, A2 is the displacement of the another wave, then the resultant displacement is equal to here, if suppose y is equal to A1 plus A2 is the resultant displacement. So the resultant displacement at any point in the medium is equal to the algebraic sum of the, that means this is the algebraic sum of the individual displacement. It is the individual displacement of the one wave is A1, another individual displacement is A2, then the resultant displacement is equal to here at any point in that is equal to the algebraic sum of the individual displacements of the wave. It is the statement of the principle of superposition of wave. So if suppose I will draw another diagram, if it is the one wave, if it is plus A1, and if it is the dotted is the minus A2. So then if suppose y is equal to A1 plus, here it is the minus A2, I am adding. So if suppose it is a 4, if it is also minus 4, then the resultant is equal to 0. So here the crust is superimposed, that means overlap with the trough, then we are getting the resultant displacement is equal to, for this case there is no amplitude. Here the amplitude will become 0 amplitude. 0 amplitude. How we can find out the resultant amplitude or the resultant displacement of this vibrating particle? The resultant displacement at any point in that medium is equal to the algebraic sum of the individual displacement. So the resultant displacement at any point in that medium is equal to the algebraic sum of the individual displacement. It is the statement of the principle of superposition of waves. Okay, all of you remember this point. Simple manner you have to remember. If suppose crust is superimposed with the another crust, then we are getting the, if it is the A1 and it is the A2, then the resultant will becomes increases. Why? Because it is the plus value, it is the plus value. Then we are getting the resultant amplitude will becomes maximum. When the crust is superimposed with the another wave crust at that point, same point, at the same point here, ఈ పాయింట్ దగ్గర ఈ ఒక వేవ్ యొక్క క్రస్ట్ ఇంకొక వేవ్ యొక్క క్రస్ట్తో ఓవర్లాప్ అయితే మనకు రిజల్టెంట్ amplitude ఏమవుతుందంటే అమ్మా ఇంక్రీజ్ అవుతుంది. If suppose one wave crust is superimposed with the another wave trough, so then it is a plus A1 and it is a minus A2, but here A1 is equal to A2, then the resultant amplitude will becomes here. The resultant amplitude is, there is no amplitude. Why? Because it is at the plus value, it is the minus value, the resultant will become with 0. So when crust is superimposed with the another trough, then this type of interference is called as the destructive interference. Destructive. And it is called as the constructive. ఇప్పుడు సపోజ్ ఇది ఒక బిల్డింగ్ అమ్మ, ఫస్ట్ ఫ్లోర్. ఈ ఫస్ట్ ఫ్లోర్ పైన ఇంకో ఫస్ట్ ఫ్లోర్ కట్టే అనుకో, ఇంకో ఫ్లోర్ కడితే ఏమవుతుంది? కన్స్ట్రక్షన్ మేనర్ అవుతుంది. అంతేగాని ఇప్పుడు ఒక బిల్డింగ్ కింద ఇంకోటి మనము దీని కింద గొయ్యి దువ్వాము అనుకో, ఏమవుతుంది? ఇది మొత్తం దీనిలోకి పడిపోతుంది. అంటే ఒక దాని కింద ఇంకోటి లాగా. సో ఇలా ఒకటి పాజిటివ్ ఉంది, ఒకటి నెగిటివ్ ఉంది, ఆటోమేటిక్గా ఏమవుతుంది? మనకు డిస్ట్రక్టివ్ అయిపోతుంది. డిస్ట్రక్టివ్ ఇంటర్ఫిరెన్స్ మీన్స్, సో వన్ హియర్ ద క్రస్ట్ ఈజ్ సూపరింపోజ్డ్ విత్ ద అనదర్ trough, then we are getting the destructive interference. If suppose one crust is superimposed with the another crust, we are getting the constructive interference. So this is the principle of superposition, but you have to remember this formula. What is that? When two or more waves traveling in a medium overlap, the resultant displacement at any point in the medium is equal to the algebraic sum of the individual displacements of the waves. If suppose you have to take the waves, two waves traveling, one wave is equal to y1 is equal to x, t is equal to a sin kx minus omega t, and there is the another wave, so a sin kx minus omega t plus phi. So the phase difference between first wave and second wave is here phi. You have to take, and the phase difference is phi. So I will do once again here the calculation. If suppose what I am taken, y1 is y1 of x comma t. So then, so y x1 comma t is equal to a sin kx minus omega t. It is the one wave. And the second one is y2. Here y2 means the displacement. First wave displacement is y1. Second wave displacement is y2. A sin kx minus omega t plus phi. It is the second wave. If suppose these two waves are interfere, then the resultant displacement means, already you know the formula, it is the 1 and 2, the algebraic sum of the individual displacements. So y equal to y1 plus y2. If suppose y3 will be there, you have to add the another way. So the resultant displacement is equal to, you have to add these two. A is common here, sin kx minus omega t plus sin kx minus omega t plus phi is the phase difference. So it is a phase difference between the first wave and the second wave. So if suppose it is a sin A and it is a sin B. So what is the formula? Sin A plus sin B is equal to here 2 sin A plus B by 2 and cos A minus B by 2. So what you have to do? A sin 2 sin If it is totally x, it is also totally x means 2x. That means 2 kx minus omega t plus 5 by 2 into cos a minus b. If suppose kx minus omega t minus means this term will be cancelled. What value we are having? Only minus 5. Cos of minus theta plus cos theta. That means cos 5 by 2. We are getting. So what is the value we are getting? 2a cos pi by 2 and sine here. So 2 here cancel means kx minus omega t for this term, and for this term pi by 2. It is the expression. So it is the resultant displacement is here y. What is the general expression for y is equal to actually a sine kx minus omega t some phase y, initial phase. So you have to compare these two. It is a general expression for the wave equation, displacement progressive wave displacement equation. So you have to compare these. This term is related to the amplitude. So here a is balanced by the, that means here 2a cos 5 by 2 is gives the amplitude. And it is the sine function, same sine kx minus omega t plus 5 by 2. So this amplitude maximum or minimum is decided by the initial phase. It is a maximum or minimum. So here the amplitude is maximum or minimum. So already you know the cos 5 by 2. When it will become maximum? If suppose phi is equal to 0 degrees. Phi value is 0 degrees. If suppose phi is equal to 0 degrees, then cos 0. Cos 0 means 1. So then what is the value we are getting? This term cos 0 means what is the expression we are getting? Y is equal to 2a and sine kx minus omega t, phi will become 0. So you have to compare these two. Here the amplitude will become double if suppose there is no phase difference. Like if it is the one wave, another wave will be same manner, dotted line. So there is no phase difference between first wave and second wave. Then the resultant displacement will become maximum. This is called as the constructive interference. So then what is the condition for the constructive interference? So the initial phase phi is equal to 0 degrees or 2 pi or 4 pi, like that. So then what is the destructive interference? So destructive interference means cos value will become 0. When it will become 0? Cos 90. Cos 90 means here phi is equal to, if suppose 180 you have to take in 180 by 2, then we are getting the value 90. So phi is equal to, if suppose phi is equal to pi or 2 pi, sorry, phi is equal to pi or 3 pi or 5 pi. So for this case it is a 2n pi, or in case of destructive interference 2n plus 1 pi. Okay, so all of you once. So here what is the statement of the principle of superposition of the wave? First, it is the statement. When two or more waves traveling in a medium overlap, the resultant displacement at any point in the medium is equal to the algebraic sum of the individual displacements of the wave. So you have to add these two, the resultant amplitude. So you have to take the two waves. So the resultant wave means you have to add these. So we have to add it. So we are getting one condition for the constructive and a destructive. So for constructive manner, it is a condition for amplitude will become maximum 2a, and destructive means, so here the constructive manner diagram, if suppose these two are the constructive, so upper and upper here lower and lower. That means the crust is superimposed with the crust, then the resultant will becomes maximum. Here the crust, so it is the out of phase with this one, so it is the destructive interference, then we are getting the wave will be, there is no, why? Because here the amplitude will becomes 0, so it is the destructive interference. Constructive interference and destructive interference. Okay students, bye.